This video will talk about IEC 60601 energy determination with the Defib 5 using the Excel method. IEC 60601-1 Issue 3, paragraph 8.5.5.2 outlines the procedure to conduct the energy reduction test to test the delivered defibrillation energy when the device under test is also connected. To run this test, the Defib 5 is configured to deliver a 5,000 volt pulse through the 400 ohm load using the 25 millihenry choke. Two tests are conducted, one with the device under test connected to the output of the Defib 5 and one with no connections to the output of the Defib 5. The energy delivered to the 100 ohm load with the device under test connected must be within 10% of the energy delivered with nothing connected to the Defib 5. The energy delivered to the 100 ohm resistor can be calculated using the energy port located on the back panel of the Defib 5, a digital oscilloscope capable of downloading data to a connected personal computer in Excel format, and the Excel file we have provided for your use on our website. This video will cover the capture of the waveform, and a subsequent video will cover the Excel procedures needed to calculate the energy delivered to the 100 ohm resistor. The following procedure can be used for capturing either waveform, that is, with or without the DUT connected to the Defib 5. First, configure the oscilloscope to capture the entire waveform. It is required to capture the tail of the waveform until the waveform approaches 0 volts to properly calculate the energy contained in the waveform. We use a Tektronix P6015 1000-to-1 oscilloscope probe which has sufficient frequency response to capture the waveform accurately. If you are using a different 1000-to-1 probe, please be sure it has a frequency response equivalent to the P6015 of 75 MHz minus 3 dB and a minimum voltage rating of 5 kV. The P6015 must also be trimmed for use with your oscilloscope per the instructions in the P6015 manual before using it to obtain waveforms. The digital oscilloscope we use is an Agilent DSO3062A, and your scope may have different methods to adjust settings than ours, but the methods we show here can be applied to any digital scope with 60 MHz or better bandwidth. Using a trimmed P6015 with our Agilent DSO3062A, we will describe the method used to capture the voltage waveform for the 100 ohm resistor internal to the Defib 5 to an oscilloscope. First, connect the probe BNC to an input channel of the oscilloscope. Then, connect the energy measurement port on the rear panel of the Defib 5 to the 1000-to-1 probe tip. Connect the ground port of the rear panel of the Defib 5 to the black cable of the probe. Adjust the oscilloscope for 1 kV per division and 2 milliseconds per division. Next, adjust the trigger level of the scope to approximately 1 kV. Then set up the scope so it will capture a single waveform. In the case of the DSO3062A, then the single button is pressed. Press charge on the Megapulse Defib 5 and wait until the input voltage shown on the front panel display is 5,000 volts. Press trigger when the front panel display shows 5,000 volts. The voltage waveform of the 100 ohm resistor internal to the Defib 5 is now displayed on the oscilloscope. This waveform is now captured and can be saved for export and further manipulation by Excel, as described in our video, Energy Determination Using Excel.
For more information, please visit Technical.